So we're going to talk about earthquake waves now and earthquakes. Earthquake is just a shaking of the ground, caused. Oops, sorry about that. Causing the release of energy. Um, this release of energy is really where two plates have come together. Oftentimes it's this. It's not always this, but oftentimes it's where two of those big lithospheric plates that we'll talk more about when we get into plate tectonics, but where those plates, and we've talked about them in 8th grade, so this should be totally new to you, but where those plates come together, they are moving and they're pushing against one another, and that pressure that builds up is released all of a sudden. And once it's released, you get the earthquake waves emanating out from that one point. You can also get earthquakes from buildings collapsing, or even meteor impacts, or even a nuclear bomb blast. Nuclear bomb blasts have very unique energy waves. We can tell if somebody does a nuclear test halfway across the world. Seismologists can see the signature is very different from a regular earthquake, and so that's how we um, manage these international treaties um, that are that countries are responsible for when they say they're not going to make nuclear bombs. Most damages that occur cause buildings to collapse or be weakened, bridges collapse. Oftentimes get lots of fires because gas lines break and release that gas into the atmosphere, into the house, and you get a little spark, and boom, you get a house fire or a gas fire. And lots of times the buildings, especially in large cities where buildings have fallen, debris has fallen into the streets, it's very difficult for firefighters to get to those houses that are on fire, so you get lots of damage by fires. Water shortage because water mains break, water lines break, and so you'll get um, people without water for long periods of time. There's two terms that you'll need to know here: focus and epicenter. The focus is located underground, the actual spot where the movement or break occurs. The epicenter is the place directly above that focus. So it's located directly on the surface above that focus. So lots of times these earthquakes occur because rocks break 50 miles, 25 miles, 5 miles under the earth, under the ground. And it's we talk about the epicenter of the earthquake as the location on the Earth's surface where that is above where that break occurred. And so that's what we'll mostly talk about are the epicenters because we think of the place where the earthquake occurs as a physical place on the surface. But realize that that may not be where the pressure built up. It may be deep underground where the pressure built up. And most of the earthquakes occur along plate boundaries. So where two plates are coming together. Not always, but often. And this is just an example in your notes of an epicenter and a focus. The foci or the focus of the earthquake happened down deep underground, and we say that the place on the surface is where that epicenter is. Now, when an earthquake occurs, we'll get different waves coming out of it, and these waves have very specific and very unique characteristics. The first waves that arrive, so the first, all these waves are emanating out from that point where the focus is, and the energy is released, and the waves that are first to get to your location, the first waves you feel from an earthquake are called P waves. That stands for primary wave. They are also, the P also stands for the back and forth motion. It's moving parallel, the particles are moving parallel to the direction of the wave motion, the energy motion. So if we take a slinky, and I'll show you this in class, that if you push it together and pull it back, a really quick motion with your hand, you'll create a wave. This compression will move it way down the slinky. The slinky particles are just moving back and forth. These travel the fastest, and they arrive first at any location. They can travel through anything. They can travel through solids, liquids, or gases. And this is how we hear things. Sound travels through air because when I speak, the air is vibrating back and forth, and that sound wave is traveling through the air and it hits your eardrum. And your eardrum starts to vibrate because of the energy that is created in the air. And that motion back and forth makes your eardrum vibrate at the same rate, and then the little bones inside your ear vibrate, and you hear that sound. The other waves that occur are called S waves or shear waves. They're also secondary waves. They're the second waves that arrive. So the P waves arrive first, primary waves, S waves arrive second, shear waves. They're called shear waves because of the motion of the particles. Here the motion is perpendicular to the way that the wave is traveling. So if the wave's traveling from left to right, the particles are moving up and down. They travel about half the speed of a P wave, but they only travel through solids, and I'll show you a demonstration of that in class. But I do want to show you this one little animation, and it shows really well what's going on here. The primary waves are longitudinal waves. You can see there's this sort of plunger pushing, creating energy, and creating the wave. And if you look at just one of these particles, just one of these particles is just moving back and forth. If you follow them, they move back and forth like this. The particles aren't moving down here, but the energy is causing the particles to bunch up and then to spread out. It's called a compression and a rarefaction. And when that happens, you get the energy traveling through the medium, whether it's air, solid, whether it's water, a liquid. It moves through that liquid and or that material and ends up wherever it stops. So if you're standing here, you'll feel those earthquake waves, those P waves, move the ground back and forth. Here, the particles are moving side to side, or perpendicular, so you can say up and down. It could be side to side, but they're moving perpendicular. You can see them moving up and down here to the way that the wave is traveling. And this wave is traveling down this material, and this only travels in solids, and we'll talk about why that is. And so that's just a way to imagine what's going on there. I'll also show you a way to look at it in class as well. Now, earthquake waves, we measure earthquakes based on two scales. One which you're most familiar with is the Richter scale. It measures earthquake magnitude using what these things called seismograms. And so we'll talk about seismograms more in class, and I'll show you some examples of them. But they basically measure ground movement, and they record it on a little piece of paper. And they are like little squigglies on a piece of paper. And sorry, I don't have one here to show you, but I'll show you in class. Each successive number, as you go up, if you look at the scale on your notes at the top right there, you'll see it's 10 times greater than the previous one. So if we start at a number 1 earthquake, a magnitude 1 earthquake, and we go up to a magnitude 2, it's 10 times greater than a 1. A magnitude 3 is 100 times greater than a 1. And a magnitude 4 is 1,000 times, and so on. You multiply it 10 times each time. So you can see that going from a 1 to a 4, as opposed to going from a 1 to a 7, it's a pretty big jump. It's not just 3 times greater. It's 1,000 times. So realize that's that scale, how that scale works. The other scale that we use is called a Mercalli scale. It's primarily used for older earthquakes in the past to measure how big they are from first-hand accounts. But they also, the National Geological Center in the government actually measures earthquakes using this sort of Mercalli scale. If you feel an earthquake, you can go to USGS and report what you felt, and it can help create a map of where the damage is in the earthquake, and then it will allow them to get better records and to know more about that earthquake. So it's based on personal experience. Did the books fall off of the bookshelf? Did you have cracks in the plaster? Did windows break? Those sorts of things that people experience are what we use. But it's subjective because you may be in one area and the ground underneath your house may propagate or move those waves more easily, and so you'll feel it more as somebody that's just down the road and if the geology is a little bit different, they may not feel it as strongly. Or even somebody in the same house. If you're in the basement, or as opposed to being up in the top floor, second floor, third into an attic, you might not feel it the same way. And so, because of that, it can be subjective as to how you feel those earthquakes. So, the Mercalli scale is good for looking at just what people experience, but the Richter scale is what we use when we're trying to compare the amount of energy that's being released by these earthquakes. So you don't have to finish the rest of those notes. We will